what your answer looks like than you are about getting to the answer. Do you understand what I'm saying? Like, I'll write an answer and you'll be all like, well, I put my exponent, my x cubed at the end instead of at the front, and is it right? Oh my God, of course it's right. Stop worrying about the way your answer looks. Spend more time making sure that you've gotten to the right answer. Okay? So, everything highlighted in yellow is fine. Just understand that the green and the blue are the same thing, and everybody knows why, right? The reason I'm stressing about this is because I already showed it to you once. Too many of you, if I give you something like this, 3 plus 7x over 3, too many of you will cancel that and tell me the answer is 7x. And it's not. That's why I'm making such a big deal now about splitting this up. It's just to reinforce when we get to this unit that those are separate things. That 2 is under both of these terms. Okay? That's why. And then we're down to here. Oh, sorry, I lie. Anybody want to ask about any of those? Everybody sees what we're doing? Right? Distribution, the 3 went to both of them, right? Grade 10, polynomial distribution. Okay. This one, of course, I would simplify into 30 root 2 minus 20 root 6 over root 5. Is this okay for me to do at this point, or do I actually have to still do the factor trees? Don't feel ashamed if you still want to see the factor trees. I don't care. But it just cuts into time in class that you could have to be doing work. Jovan. Yeah, negative 10. Sorry, I brought out a 4. Okay? And then, of course, I'm going to multiply by root 5 over root 5. Distribute 30 root 10 minus 10 root 30 over 5. Now, of course, you can already see 30, 5, 10. You're going to be able to simplify everywhere. 6 root 10 minus 2 root 30. And then you can't simplify either 10 or 30. And then this one is going to be 45 root 2 minus 33 root 2 over negative 3 root 8, which is going to be 12 root 2 over negative 3 root 8, which is going to be negative 4 root 2 over root 8. You could simplify root 8, or you could just multiply by root 8, which gets you negative 4 root 16 over 8, which gets you negative 16 over 8, which gets you negative 2. Can everybody rationalize a denominator? A monomial denominator. Everyone is good? Remember, when it's a monomial denominator, the only thing we care about is the radical. That's all we have to deal with, right? We don't have to deal with the coefficient. Everybody good? Okay. Let's turn the page over to binomial denominators. Now, just to remind you, I want you to do a monomial one by yourself up here. 3 root 7 plus 8 root 28 over root 3. 2 root 3. All of you do that one, just to make sure. Because I noticed a lot of people are writing down what I did as notes and maybe not doing it themselves. Yes. Oh, thank you. That font is called Char BB. Most of them, because I choose them. I go through font lists and I say, ooh, I like that one. Yes, it's on fire. You are indeed killing it. The way oh yeah, you're killing it with fire. I like that too. I never thought of that one. So of course, what are we going to do first? I would simplify the root 28 to get 3 root 7 plus, that is 7 times 4, so that is 16 root 7 over 2 root 3, which would get me 19 root 7s over 2 root 3. Now 19 and 2 do not simplify, so now we got to get rid of the root 3. So what do we multiply by? Root 3 over root 3. We're actually multiplying by 1. We're just changing the looks, right? Which will get me 19 root 21 over what? This is where kids screw this up. What is going here? 6. Root 3 times root 3 is 3, times 2 is 6. Now, 19 and 6 do not simplify. 21 is 3 times 7, no pairs. It does not simplify, so it is done. Is everybody good? You may not feel you're ready to go off and, slay the monomial denominator dragon by yourself. But if you had a group of people like Frodo and Sam did, and they go out with, Legolas and all those tough guys to go and fight, could you do it? Could you be in the group of adventurers? Okay. So what's different here? Hint, it's in the title. The denominator is a binomial now, yes? And that won't simplify, will it? 15 and 10, they don't get any simpler. Now, logically, what do you want to try here? You know you've got to multiply by 1, right? Because if you multiply by anything other than 1, you're going to change the value of this. So you know you got to multiply by 1. So whatever we're going to multiply here has to be the same thing in the numerator and the same thing in the denominator. Agreed? Okay. So what do you think we should put here? Knowing what you know about rationalizing denominators, and we just did one, what do you think we could write here? Give me some guesses. Some of you, if you're from another country, you may already know, so be nice and play along and pretend like you don't. Okay? So, somebody give me an idea. What could I write here? Knowing what you know from right up above there. What is a logical thing to write here? Why do you think root 7? Aren't we allowed to have radicals in the numerator? Okay. So if I did root 7 over root 7, that will get rid of this radical, right? But won't that leave me with radicals still down here? I'm just asking. Won't it leave me with radicals in the denominator? Right? Have we ever multiplied by the radical in the numerator? This is a yes or no question. Have we ever multiplied by the radical in the numerator? Ever? In the previous 25 questions we've done, did we ever do that? No. So we're not going to do root 7. What's another guess? Jacqueline. Root 10. So if I put root 10 down there and root 10 there, that root 10 is going to take care of that, isn't it? But what will it do when it hits that? I'll have the root of 150. So I'll have another radical under there. Agreed? Now I could then multiply by the root of 150, couldn't I? I could do 2 steps and get there. Agreed. That is one thing you could do. So don't write this down. If we follow this, then Jacqueline is going to get us, what's going to be our numerator? Don't write it down, just think. What's going to be our numerator here? Root 70 over what? Root 150 minus 10, yes? Okay, I've still got a binomial down there, right? Okay, so now what do you think you could multiply by? Don't write it down, just what do you think you could do? I could multiply by root 150 over root 150, right? Which would then get me 150 times 150 is 150, right? But it would get me minus 10 root 150. I'm still stuck with a root 150. So I cannot do that. So give me another idea. Okay, so Prab says root 15 minus root 10. Root 15 minus root 10. Okay, that kind of follows what we've been doing, yes? Right? Sebastian? Well, if I multiply by root 2, I'm going to get root 30 minus root 20. I'm still going to have roots. So what Sebastian is saying, couldn't you, some magic number that would make this a perfect square, I assume, and this a perfect square, so you could just have number minus number? Is that what you're saying?
Yeah, along lines.
Like, so if we did root x, and this x multiplied by that, and got me a perfect square.
I just meant like using a square so that you could cancel out the roots.
Yeah. I see what you're saying. That's exactly what Prab was just saying. Root 15 minus root 10 over root 15 minus root 10. Now, we've already done this a bit, right? This is just FOIL, yeah? So root 15 times root 15. Oh, that's cool. That's going to disappear, right? Don't write this down yet. Is this going to work? What's root 15 times root 15? 15. Oh, I disappeared one radical. Awesome. What's root 15 times root 10? Root 150, right? And it's going to be negative because of that. Agreed? So negative root 150. I still got a root. All right. Well, what's 10 times 15? Because we've dealt with this one, so now we got to do the 10. That's going to be a negative root 150 again, isn't it? Everyone agree? And what's root 10 times root 10? Negative 10. So I managed to make 2 of the radicals disappear, but I've still got these here, yes? So I would end up with 15 minus 10 is 5 minus 2 root 150, yes? Everyone agrees? But then if I multiply by root 150, I'm back in this trap because 5 times 150, I've got my radical again, right? But I want you all to notice, what do you see right here? 2 negatives. What if that were positive? They would cancel out, right? How would I make those middle terms positive? Where have you seen that in math class? Not quite. X squared minus 4. How do you factor that? Who remembers that? Difference of squares. Does anyone remember that? Okay. So what if I did this? X plus 2, X minus 2. What happens if I do that? What's the first term? X squared. What's the second term? Negative 2x. What's the third term? Positive 2x. And what's the fourth term? Negative 4. What happened to the middle terms? They dropped out, right? Okay. So let's look here. I want to drop out. Prab was right. We need to multiply by root 15 and root 10, or we won't get rid of them all, right? But if I do minus, we're stuck with that. But if I do plus, those terms are going to drop out, aren't they? And that concept from grade 10 of difference of squares becomes a useful concept in grade 11. Everybody cool? Now, this has a fancy name. It is called the conjugate. And the conjugate is the same binomial terms, but the opposite sign. So let's take this knowledge and let's build our answer. Root 7 over root 15 minus root 10 times. Now I have a binomial, so I have to use the conjugate. And I'll use a different color. Root 15 plus root 10 over root 15 plus root 10. Is this still 1? Right? This is still 1, right? So value's not changing, just looks. Now, I'm going to write it out completely. Would you write it out completely? Maybe you would, maybe you wouldn't. But I'm going to do it completely. No work in my head. I'm going to show everything on the paper, all right? So this first one is going to be the root of 7 times 15, right? Plus the root of 7 times 10. Yes? Over the root of 15 squared, because 15 times 15, yes? Right? Plus the root of 150. Oh, sorry, I said I was going to write it all out. 15 times 10. Then minus the root of 15 times 10. And then minus the root of 10 squared. 7 times 15 is 105. Plus root 70. Over, what is the square root of 15 squared? 15. These two drop out. Minus, what's the square root of 10 squared? 10. To get root 105 plus root 70 over 5. Am I done? It looks like I'm not done because I see 5s and 0s, don't I? I want to divide. Well, can I divide this radical by this integer? No. Okay, can I simplify this radical? That's 7 times 15. Are there any pairs in there? It's 3 times 5 times 7. Are there any pairs? No. 70 is 2 times 5 times 7. Any pairs? So no simplifying there. And I can't divide because these are radicands. So am I done? Yes. What's the only new thing you learned? Conjugate. That's it. Because you already know how to do double distribution, don't you? And you already know from difference of squares in grade 10 how to make a middle term drop out. Everybody cool? All right, so let's look at our very first question. No, I got it. All right. Look at this. Does B look the same as the first one? No, something is slightly different, right? What's different? I have a coefficient. Now, did we need to worry about the coefficient when it was a monomial? No. So, don't write this down. If I just said go, you would probably try, you would say, oh, that's a binomial, I need the conjugate, and you would probably do root 3 minus root 2 over root 3 minus root 2, because you'd say, I don't need to worry about the coefficient, because I didn't need to worry about it yesterday, right? Of course you have to worry about it. You know you have to worry about it because of the way I'm setting it up, right? If we did this, I would get 2 root 9, right? That's cool. Minus 2 root 6. That's cool. And then what would happen when I did root 2 times root 3? It would only be 1 root 6. Would my root 6 disappear? No. So when we have coefficients in a binomial denominator, we must use them. We didn't have to use them when it was monomial, but we have to use them when it's a binomial. Everybody good? Does anything else change, do you think? No, of course not. This is just complex because we're doing double distribution now twice. But it would be no different than giving you A, some double distribution, and B, some double distribution, would it? So, what is the numerator going to be? That's the first one. What is it? Six root 6. Okay. That's the second one. What's that? Three root 4. 2 times 2. Here's the third one. What's that going to be? Plus 2 root 9. And here's the fourth one. What's that going to be? Minus root 6. Over. Now, we've done it once before. If it happens once in math, how often does it happen? Always. So do I actually need to do double distribution down here? No, because I know I'm going to get left with that times that and that times that, because I know the middle term is going to drop out. Right? So all I got to do is the first two. So in yellow, what's 2 root 3 times 2 root 3? 4 root 9. Right? And we know it's going to be a minus, and then in green, what's this one going to be? It's going to be root 4. Right? And now I just simplify. I got 6 root 6's there, and I'm taking away 1 root 6 there. How many root 6's are left? Really? No, don't be silent now. I have 6 and I'm taking away 1. How many are left? You thought you were wrong when you did 6 minus 1? No, I'm sighing because it was silent while 30 of you puzzled through 6 minus 1. That's why I sighed. Because the only thing that would have made me more sad was hearing the tick, tick, tick of fingers on calculators for 6 minus 1. Yes? For the positive? because it doesn't cancel. It's still... No, it's still going to be negative root 4. Because we're multiplying, right, Bea? And what is 3 times the root of 4? 6. And what is 2 times the root of 9? And what is negative 6 plus 6? Negative 6 plus 6, ladies and gentlemen. 0. Over, what is 4 times the root of 9? 12. What is the root of 4? 2. 5 root 6 over 10. What is the last thing I'm going to do? Simplify what? Because root 6 doesn't simplify. 5 over 10 becomes 1 over 2. Root 6 over 2. Now please notice, nothing new today. Again, even that word conjugate, you already understand why that works because you've already done difference of squares. Right? You've already done double distribution. But I do want to remind you that whether or not you know everything to do, it is still quite complex, isn't it? The work may be easy, but to put it all together is very complex. And I always use the example of building a house. If I want to build a house, really, all I need is a hammer, nails, a saw, and some wood, right? Is it that easy to build a house? Of course not. I could not build a house, even though I can hammer 2 pieces of wood together as well as the next guy, almost without ever hitting my thumb. But that's not what it's about, is it? So let's look at the next one. The next one is easier because there's a monomial on top. Right? So everybody, what would your first step be? I would simplify the 12. So this would become 2 root 2. I'm using the thick felt. It's a pain. Over. That is, of course, 6 root 3 minus 4 root 3. Yes? Now what would you do? You can actually simplify the bottom now, can't you? You don't need to do the conjugate. Right? And this becomes 2 root 2 over 2 root 3. What are the 2's going to do? Cancel, and I'm going to be left with root 2 over root 3. Now, a great many of you would stop there because you've done a bunch of math. Can you stop there? Why? Can't have that on the bottom, so it's root 3 over root 3. Root 6 over 3, and there I stop. So again, do not be fooled by something that looks like a binomial if you can simplify. Everybody good? So let's review for a second. What do we need to do today's work? 1, I need to know how to simplify radicals. You can all do that. Some of you take longer than others. Some of you have to build bigger factor trees, but you can all do that. 2, you can have facts that you need to know. You can't have a radical in the denominator. Well, I know how to get rid of a radical. I multiply it by itself. All right, done. It's a fraction. If I multiply the bottom radical, I got to multiply the top. Done. Is it a binomial? Yeah, it is. I got to make sure the middle term drops out. So I got to do difference of squares to make that middle term drop out. 3 things you got to remember to do all these questions. But takes a lot of steps. Now, does it need to take that many steps? You can do some of this in your head. But if you're going to do the stuff in your head to save yourself the work, you better make sure you're doing it in your head properly. Everybody understand? And when I show you the right answer and you don't have what I have, and you check with me like, oh, Mr. Myers, I got this, and I look down and say, oh, crap, I forgot this negative, which happens. But if I look down and I'm like, I don't know, you need to know where your error was, because I can't help you unless you've shown me some work or know what you're doing. Everybody with me? All right, let's try a couple together, then I'm going to shut up and let you work. Yeah, go.
Could you go back to the, I know it was before, but I was still wondering, what did you do with the 3 square root 4?
Well, what is the square root of 4?
2.
What's 3 times 2?
Oh, okay, sorry.
No problem. All right. What's different in D? And a corollary of that question is that difference anything that we need to worry about? No, it isn't. There's just a variable in there. We could simplify now, or because it's such a tiny number, we could simplify later. What do you want to do? For me, I'd simplify now, even though it's so easy, because I want to get in the habit of simplifying every time. So what does this become? That's going to become 6 over what? 2 root x plus 1. Now, do I have a radical in the denominator? Yes, so I got to get rid of it. Is it a binomial denominator? Yes, so I got to use the conjugate. What's the conjugate of that denominator? 2 root x minus 1 over 2 root x minus 1. And then we just do our work. What is 6 times 2 root x? 12 root x. What is 6 times negative 1? Negative 6 over. Do I care about the middle, or do I only need to do firsty and lasty? Firsty, lasty. 2 times 2 is 4. Root x times x is x squared. Root of x squared is x. So I get 4x plus what? Not plus, sorry. 4x minus 1. And then I'm done. There is one step further I could go, but that would require me to remember factoring. Now you notice I got a whole unit coming up on polynomials. I'm going to remind you about factoring, but I have some textbook sheets in here that are going to show the right answer that's been factored. So you may look at this and see 12 and 6. You may take a 6 out of there and get 2 root x minus 1 over 4x minus 1. These are the same answer. And at this point in the year, before we've reviewed factoring, I'm perfectly happy if you stop there. Okay? I'm only making a big deal out of it because I can't remember if I've given you any answer keys that take it this far in this unit. Okay? I just want you to see it so you're aware that you may very well have the right answer. They just did that one more step. Is everybody good? Yeah. All right. Now, look at E, because E is weird. What's weird? Is that a monomial or a binomial denominator? What do you say, Sebastian? You say monomial? Everything's covered by the square root, right? So if I were to get rid of that square root, what would I multiply by? The root of 4x. Root of 4x. Now, do I need it to be the conjugate here, do you think? No, I don't. Because once I square it, it's going to disappear, isn't it? Everybody understands? So what am I going to have in the numerator? What am I going to have in the numerator? It's just 6 root 4x plus 1. Over what? 4x plus 1. And you can't simplify that. Because this doesn't break down because it's got the plus. Everybody cool? Are we good? All right. You have a look at F. Because when I write it this way, kids have trouble with it. That is not an index. That is a coefficient. Yep. I'm going to turn this off so you can pay attention at your feet, at your desk. What are you doing there? Anyway, there it all is. You knew how to do it anyway. Listen, please. Thursday morning, I have to go to a meeting. I'm not going to be here. I believe Thursday is a day 1, A, B, C, D, which means it will affect you people. Just let me double check. A, B, C, D, and X block. Nobody signed up for X blocks. That's not a big deal. But if you're planning to, I'm not going to be here. Okay? And I'm not going to be here for block A. So here is what I want to do. We're done the new stuff for this unit. You will notice that the next thing on here, after page 50, you see I have a quiz. And then 2.6. 2.6 is your review for this unit. It's all the radical stuff. So here's what I want to do. I want to go over 50 tomorrow, up to page 50, and I want to do that quiz. Everybody good? We'll do the quiz, we'll mark the quiz, we'll go over it. It'll probably take most of the day. I want to give you all day in class Thursday to do this review. It's like page 51 to 53 or something. I want to mark that Friday. Friday, we will move on to our new unit. This is a review, which you will get marked Friday, which means you can expect a test any time next week. All right? Now, those of you that are in my class before know I do not like to give tests on Monday. I do not like to give tests in the first block. That does not mean I won't. I just don't like to. At the beginning of the year, we have a bit of a cushion. It's not a problem. As we approach the end of the year, maybe I don't have a day to give you to work on a review. Maybe we are writing a test on a Monday. Maybe it's first block Monday. It might happen. But at this point of the year, I don't like to do those two things, so you can pretty much guarantee that that test won't be happening Monday. Tuesday, you're in here last block. If I were a betting man. All right? Yeah, go now. Yeah. Okay? Go.